Alright, grade 11s, this is just the last trig video before the trig functions. It's called values for which identities are invalid or undefined. We also talk about them being undefined. So either word could be used in the question. So there are three main situations for where an identity or a trig situation is invalid or undefined. That's if your denominator is 0 in a fraction, but that applies to all situations in maths. If an identity is in the form where you have a root and you end up getting a negative under the root sign. So it doesn't have to only be cos like in this section, but you can have sine, tan, any negative under the root sign that's is going to make your question invalid. You've got to account for that. Then an identity that has tan in it, the second you see tan, you have to just use this 90 plus k 180, and don't forget k is an element of integers, and that is for the asymptotes of tan. So it starts at 90. If I add 180, then I get to 270. That's the other asymptote. If I subtract 180, I get negative 90. If I subtract another 180, I get negative 270. And the asymptotes will keep repeating every 180 degrees from 90. So the second you see tan in a question, you just copy out the asymptote general solution. Alright, so we're just doing these two examples, A and B here, and really it doesn't get asked very often. So when we're working with identities being undefined, often it will come within another general solution question. So it says, consider the identity tan x cos x over sin x equals to 1, for which value of x will the identity above be invalid? State the general solutions. They won't always tell you to state the general solutions. Sometimes they'll just say, where is it invalid or undefined? You always do the general solution. All right, so then the fact that I'm seeing a tan there, that's going to be an issue in our life. So tan is going to be a problem. It's going to have undefined spots on its asymptotes where the graph doesn't exist, and also this denominator cannot be 0. Now, in that situation, we don't want to know what it cannot be. We want to know where it will be undefined. So please don't cross off your equal signs. We want to know which regions, which numbers will make this graph not work or make the situation not work. So we want the values equal to. All right, so it's going to be undefined for sin x equals 0. So please don't cross that off. We want to know when it's going to be undefined, and for tan's asymptotes. So for sin x equal to 0, you've got sine angle equal number, so you can go shift sign on your calculator of 0 degrees, and that just gives you 0 plus k360 or 180 minus your 0 plus k360. Remember, as soon as you click shift on your calculator, you apply the general solution. And then for the first one, you can just write it as K360, and for the second one, 180 plus K360. K is an element of integers. Then for tan, for its asymptote, just remember that it's always the same formula for tan's asymptote, and that is 90 plus K180. And K is also an element of integers. So whether tan is at the top or the bottom, you spew out 90 plus K180. Right, for the last one, it says consider the identity tan theta plus cos theta over 1 plus sin theta equals 1 over cos theta, for which values of x is the identity above undefined for the interval of theta is negative 180 to 180. Also, just please note that these are round brackets, so we can't include negative 180 and 180. Here, straight away, I'm seeing a tan, so it's got to be 90 plus k180 for tan's asymptotes. Then we've got to think about 1 plus sine theta equal to 0. So I'm going to get my 1 across and make it negative, and then do my general solution. So shift sign in your calculator of negative 1 is negative 90 plus k360, or we're working with 180 minus that negative 90 plus k360, which gets you 90 plus k360. And then we also, on the other side, have a cos theta. So it's going to be where cos theta is equal to 0. right? So cos theta equal to 0. So theta is going to be shift cos of 0, which is 90 degrees, but for cos it's plus minus 90 degrees plus k 360. All right. So if we look at all of our answers now, the yellow, the blue, and the original tans asymptotes here, let's highlight that in red. So the red, the blue, and the yellow, they all overlap on the answers. So what actually works for all of them fit under the bracket of theta is equal to 90 plus k 180. So in other words, if I were to use 90 degrees, it would fit between negative 180 and 180. If I were to add 180 to it, it's going to get me bigger than 180, so I'm out of my domain that they've given me, my restriction that they gave. They gave that restriction over here, and if I subtract 180 from 90, it gets me negative 90. So I get from the sine one, I get negative 90, and I get the 90 plus k 360, and here I get the plus minus 90 anyway. And I know it's by 360, but if you add 180 and then add 180 again, it's 2 hops from the tan one, but it's actually just one lot of 360. So the 180 will get you the same effect as the 360s. So you work off just the one that you need, and you get the answers that fit in the domain. All right, so it's saying if we make our angle in our question negative 90 or 90, this is not going to work within the interval of negative 180 to 180. All right, so 90 and negative 90 are the values that will make this undefined. So don't cross them out. We want to know what are the values. All right, and that's it for identities undefined. All right, so you can work on exercise 13 in your textbooks, A, 1 and 3, and B2. That's all you really need to practice. That it doesn't come up very often, and it's worth maybe 2-3 marks when it does come up. And a lot of the time they put a tan in so that you can just stick the 90 plus k 180 for the asymptotes, and sometimes the denominator one. So it's very simple, it's very quick, so don't focus too much on it. And then that's it for trig. I'll put up a video about trig functions, but the actual main trig part is now done.